Hey, hello guys, a very happy morning to everyone of you. And guys, now we are just going to see about the thermodynamics because in the previous sector I just told about a lot of problems about to you, okay? So in this sector we are just going to cover the extra problems, okay? So I think so without wasting time, let us just start up. So just wait one sec, whether I just completed or no, I think so I will complete this, okay? Okay. Okay, you can just start with the questions. It's okay? Just one second. So the first question I think so you can note it down. Okay, now it's perfect. Okay, the first question you can just see it down. Okay, so first I'll just read the question. So okay, a mass of gas has been asking 2020 to be okay. Mass of gas m equal to, first question, m equal to 3 kg of argon, pressure 1 3 bar, and T1 27 degrees Celsius. Okay, kindly rigid and insulated with Q equal to 0. Pedal wheel is work, okay, pedal wheel, okay, 30 minutes. Work done on the gas, okay. So minus, okay, work is minus of 0.015 kilowatt, okay. So basically the CV is given 2 kilojoule per kg. The final temperature T2 is how much, okay. Rigid, okay, rigid is been insulated, so like this is been given, okay. So definitely what will be the thing, Q equal to W plus of delta U, okay. This 0 and W equal to minus of delta U, okay. This is M CV T2 minus of T1, okay. So in this side how we can just write, this one will be 3 kg into 0.3122 kilojoule per kg Kelvin. So the second kilojoule per kg Kelvin. So this one T2 minus of T1. T1 is 27, 273 of 27, around 300 Kelvin, okay. So this side work is minus of that, so minus gets cancelled, and this one is 0.015 into kilowatt. So watt is joule per second, so into 30 minutes we have to just convert seconds, okay. Now we just calculate and we can calculate the T2, okay. That's it. Okay, you can see this one, so it's so much easy. I think so you can easily calculate it, okay. So you can just go for the next one. I think so I just completed this question because some of the questions I think so I just completed. I'm just a little bit quite confused, okay. Yes, until this question, yeah, yes. For the first 4 questions we are just completed. The fifth only we need to just start, okay. Because in this question I think so I would have already told to you, okay. So you can just go for the fifth question. Air is held inside, okay, non-insulated. So okay, this one is atmosphere, this one is also atmosphere, and the peak initial, okay, P temperature initial, this one. Mass, okay, mass, oh, piston mass itself, okay, and then this piston mass goes downwards, okay. Mass is 25 kg, so it will definitely compress the air everything inside. So initial pressure, so what they are asking, the temperature of the air inside this cylinder, which the piston makes us to move. Okay. So they're asking at which temperature the, it means at which temperature, it means definitely I'll just explain to you. So I'll first explain the question. For example, this is the cylinder, okay. So definitely it's a constant pressure process, okay. So piston will have weight and the Q will be just going out, okay. and the piston is just compressing this, okay. mm, so Q equal to W of delta U, okay, change in internal energy. So it is constant pressure process, okay. mm, because and also we don't know it means how the Q is been changing, okay. Okay, such a good interesting question in my point of view. mm, W equal to PdV. So volume, okay, volume, okay, this one doesn't consider. Volume is constant at this time, okay. mm, PV equal to MR of T, okay. So volume method they have just given, area is given, height is given. Area, okay, no, height is not given. So specific volume also we can't just calculate, and since we don't know, okay. Mass by volume, density of air, but what is the use of calculating density of air? mm, mm, T1 P1 1 minus gamma by gamma equal to T2 P2 1 minus gamma by gamma. So T1 V1 1 gamma minus 1, T2 V2 gamma minus 1, P1 V1 per gamma, P2 V2 per gamma, okay. Really guys, this is such an interesting question in my point of view, okay, because we need to calculate the P2. Suppose you can see this one. So T1 we know, T2 we know, P1 we know, okay. If we just find out P2, what is the pressure P2 means, we can just easily calculate, okay. So this is constant pressure process, PV equal to MRT, okay. So since constant pressure, V will come, so MR of T divided by V equal to MR of T divided by V, okay. So mass gets cancelled, so even so weight is given, okay, and what will be the thing? See guys, taking this much time is not good, but okay, just think, since the pressure is given, okay. So mass into gravity, kg meter per second square, okay, it comes as Newton. Weight equal to mass into gravity comes as Newton, okay. So Newton is it means what is the unit of Newton? Force equal to pressure equal to force applied over area, okay. Or it means pressure is Pascal meter square. So everything is either okay, you can see this. So definitely the it means, for example, you can just take like this, okay. The air inside will just oppose, and the piston and as well as the pressure outside will just try to compress, okay. So you can see the piston weight is mass into what ton of atmosphere, okay. Area, see, simple calculation guys, I'm just getting anger against myself itself. See, this one we need to just consider. That is the thing, stupid. Literally, I'm just getting anger against myself. You can see this one. So this one is a PA equal to pressure atmosphere, A plus of work, okay. you can see this it means the pressure we need to find. Okay, so you can see what is the pressure. So weight equal to, okay, pressure as atmosphere, 100 kilopascal, okay, into what is an area, 100 centimeter square, okay, plus of weight is 25 kg, mass into gravity 25 kg into 10 meter per second, okay, meter is 1 meter equal to 100 centimeter, so 10 into 100 centimeter per second, okay. So mass into gravity, you can see the equation is not valid, okay, because this is kg, this is Pascal is Newton per meter square, okay. So we need meter square, so we need to convert the entire thing. So this one area is which one? So this P2, so it means after that, it means see, this is all initial condition. So just light step down means you can see at the time the pressure will reduce as well as the temperature will reduce, but the area will be remaining as it. So calculate this one is a P2, okay, and after calculating put here, that's it. See, as I just told to you before, okay. See what is the thing I just told. Pascal, this one mg and this one area, okay. Calculate the P2 according to this, and at initially you can see, they suppose it's still, so why? Because we don't know the gamma. So you can see at this thing the isochoric heat rejection will occur, okay. Okay, so at the time it means volume will be constant. So P by T1 equal to P2 divided by T2. Oh, wow, such a simple question. You just see how much problematic it has become to us. Okay, it was one of the good questions. So you can just go to the next question. You can see a rigid insulated vessel is divided into two components by rigid into two components. Okay, one component is 12 kg, 200 kilopascal and 280 Kelvin. Okay, the other component is 26 kg, 400 kilopascal, 360 Kelvin. Okay, the specific heat of oxygen, one side is oxygen, other side is carbon dioxide. The water is removed, now considering the final temperature. So definitely the temperature will keep on increasing, and if it is insulated rigid vessel, insulator, and what? So Q equal to W plus of delta U. So this will be 0, this will be 0, no wonder. So delta U, you can see, so U1, this one delta U is U1 plus of U2, okay, U, this one oxygen, this one carbon dioxide equal to 0. So you can see it means what is the thing, M, Cp or Cp, it means for specific oxygen, C or oxygen, T2. So definitely you can see this side temperature will increase, so 2T final minus of T1 plus of M of CO2, it is a specific heat of CO2 of T, and this one 360, 3C definitely this will F, okay, equal to 0. So now we can calculate each and everything, we will just calculate the T of final, okay. Not a difficult thing, simple only. You can see this one, okay. Okay, I think so you can understand. So yeah, just is answerable, that's it, okay. I think so you can understand. Wait, anyways, I'll just write it down, okay, so you have a clear cut understanding. M is 12 into CO2 is for this one is 0.0662, 0.662, it means kilojoule per kg Kelvin, okay. This one is T final minus of T1 is 280 Kelvin, okay, plus of, and this one is 26 into CO2 is 0.653, 360 minus of TFF, okay, 0. 12 into 662 into this one, 7.944 Tf minus of 280 of Kelvin equal to, so this one, so plus of 26 into 0.653 16.978. okay, so 360 minus of Tf equal to 0. So put this outside, 7.944. So minus of 16, so we can just put 16.978 Tf minus of 360. This one, okay. I think so, getting the point. So Tf minus of 280 Kelvin with Tf minus of 360 Kelvin equal to 16.978 divided by 7.944. So 2.137 into, so Tf minus 280 Kelvin minus equal to 2.137 Tf minus of 769. okay, put this side, okay. 1.137 of Tf, okay, minus of 280 divided by 1.137, 430 r. Guys, I think so we are doing some kind of mistakes here, okay. Maybe we are doing any kind of calculation mistake or any kind of other mistake in my point of view, I think so. Okay, you can just go to the next question. So in this question you can just see, I'll just explain the basic thing. So you can see air, it is given air pressure 150 megapascal, kilopascal, temperature is 322 Kelvin, volume given rigid one 0.05 meter cube. Assume, okay, ideal gas, okay. So Q equal to W of delta U, okay. So volume is constant and the Cp R is Q neglecting, so U is added, okay. So it will be 30 kilojoule equal to rigid volume work done will be 0 m Cv of delta T, okay. T2 minus of T1. So 30 kilojoule equal to m is Pv equal to m RT, okay. Pressure given, volume given, m equal to Pv divided by R of T, okay. Calculate here and put here and we can just find the T2, okay. Okay, I think so I can understand. So we can just go for the 8th question. So 8th question you can see the molar, okay. I'll just write here 8th question. So Cpm equal to 40 B of T, this one joule kilon inverse mole inverse, okay. So okay, this is the main thing. And enthalpy changes, H1 and change in enthalpy equal to 2 kilojoule mole inverse. So temperature T1 is equal to 300 Kelvin, T2 is 350 Kelvin. So the molar heat capacity, just one second, I'll just read the question again. The molar heat capacity of a substance is represented in temperature range. Okay, the molar heat capacity of temperature range heated from 300. Two questions is been there. Okay, T1 equal to 298 Kelvin, T2 is 400 Kelvin. Okay, so the value of B. Okay, then so this is a common formula for both of the things. Okay, so definitely in my point of view, so example Q equal to, so Cp change in enthalpy is this one, change in enthalpy. Okay, for example Q equal to mc of B of 14 plus of Bt, sorry on this one. Okay, and delta time temperature, okay, of dt. Okay, this one is maybe Tq, I think so. So because joule is given. Okay, so dq equal to mcp of m of dt. So so 14 plus of bt of dt. So integration definitely we need to do. Okay, so this one you just consider dh equal to m, we don't know. Okay, 14 plus bt of dt, integration of first thing is 300 to 350 Kelvin. Okay, this thing will be, okay, can be 2 kilojoule. Okay, this one is a 2 kilojoule per mole equal to 14 T plus of B T square divided by 2, 300 350. Okay, 2 kilojoule per mole equal to 1450 will be plus of B by T. So 350 the whole square minus of 300 the whole square. So 0 2 5 20, this one 5 7 0 plus of B divided by 2 3 2 5 0 0 divided by 2 16. Okay, 2 2 into 10 power 3. What it's coming minus, so minus of 700 equal to 62500 of B. Okay, so will be 1300 divided by 16250. B is 0.08. Oh wow, perfect, 0.08. Okay, I think so I got this point. So this thing is a basic equation. Good. So guys, literally I think so I'm just taking quite longer time. Okay, so anyways I'll just try to reduce the time. Okay, so for this one you can just see behind the question, the molar heat, molar constant volume. Okay, molar specific heat of constant volume is the molar. Okay, Cv equal to 2.5 times of R of universal gas constant. This is represented molar specific heat, molar specific heat. So molar specific heat means each and everything will be same, but at the bottom it will be divided by mole inverse into. Okay, when the temperature increases by delta, the change in molar specific constant volume, Cv constant volume. So Q equal to mCv of delta T. Okay, so change in internal energy equal to mCv of delta T. So they're asking molar specific enthalpy. Okay, they are asking delta H. Minus CV equal to R bar. Okay, so each and everything. So Cp is equal to R bar plus of Cv equal to Cp equal to 3.5 of R bar. So delta H equal to mCp of delta T. So mass, whether they are just given. So let us consider 1 kg also. Kg need to just cancel. Cp is this one 3.5. R bar is how much? Three five zero. Where we are just mistake. Where is this R bar? Into 8.314. Where is this one? So multiply and we will get the answer. Okay, so this is the answer. I did not multiply this R bar. So next we can just go for this one. Consider two systems, 10th one. Two systems, okay. 20 kg of air on same temperature and pressure at same limits and pressure. So increase the temperature of the air. Okay, two systems. Oh, 20 kg. Okay, so temperature increase 10 degrees Celsius. Okay, 10 degrees Celsius. So one is at one constant pressure heat addition process. Oh, this is constant pressure, this is constant volume. So the difference in, okay, they're asking the Q of pressure, Q of volume. Okay, so minus equal to how much? So W, it means it's an easy question. I'm just doing a revision. It's such a worst thing. So you can see for constant pressure, this one will be m Cp of delta T, this one will be m Cv of delta T equal to 0. Okay, so hey, what's the problem for you, Prakash? Constant pressure, this one. Okay, whether they have just given m here. Okay, Cp, Cv, whether they have given is air. Okay, for air, what is Cp and Cv? Cp is Cv is 0.718, Cv is 1.008. So I think so I can calculate this one. Okay, it's just a simple thing. I'll just show it to you. See, each and everything is been constant. Okay, I just took it a different approach, that's it. So not a bigger difference. Okay, gamma minus 1 of QV, okay, MCV of delta T, okay, that's it. Let us try. So 20 into 0.005 into 10 is 373, 273, 283 minus of 20 into 0.718 into 283. 283. So yes, maybe I am wrong, okay. So where is that one? So you can see this one. So QVMCP of delta T, okay. Okay, so you can see this one. This entire term can be written as gamma of QV, okay. So gamma minus 1 of QV, okay. Gamma minus 1 means Cp into delta T equal to 0. So this entire thing they are asking is just calculate. So what is gamma? 1.4, okay. 1.005 divided by 0.718. Hey guys, definitely the answer will come right. Maybe I'm just doing a of calculation check only. Okay, we can just go for the next question. So you can see a parallel is a rigid, which is rigid insulator, okay, equal to W plus of delta U. Torque of T equal to 100 Newton meter, okay. So Newton meter, okay. 60 revolution per minute. 60 revolution per 2 minutes, okay. So Q equal to W plus of delta U, okay. This Q will be 0. So since torque into theta, theta is revolution, okay, per minute, okay, per minute, okay. So work is 100 Newton meter into 60 revolution per minute to 2 minutes. So 2 minutes means 2 into 60 seconds, okay, equal to the M constant pressure or constant M CV of delta T, okay. So you can see this one is Newton meter and revolution, and this one is seconds, okay. This one is definitely to be in so kilojoule, okay. You can see joule is Newton per meter, okay. So we need to convert this kind of thing into meter, means this is Newton meter. So you can see 2 pi over 100. Okay, I think so I got the point. So the unit should definitely match along with each other. Okay, so multiply according to this and you will just get each other. So you can see the Q equal to W. So W is divided into work done of pattern and plus of work done of displacement. So here the displacement will be 0. Okay, so delta U. Okay, so internal element depends on the temperature only. Okay, that's it. So you can just go for the next question, 13th equation. So you can just go for the next equation. What is Sami? So okay, a gas opening gaseous equation of a state isothermal compression. Okay, delta T equal to constant 5 megapascal to 15 megapascal. Just 1 second. My network is literally just. Okay, the Clausius equation for the pressure P equal to RT V minus B of T. Okay, the P parameters varies. B depend on the temperature. B naught plus of B1 of T. Okay. So dou H by dou P with respect to temperature equal to V minus of T dou V by dou T with respect to pressure. You're asking the H final minus of H initial. Such a big question. Okay. So how we can just calculate this one? Means you can see P1 is 5 into 10 power 3 kilopascal. Okay, everything right in kilopascal equal to R will be with this gas or anything gas. Okay, so R is universal gas constant. Okay, not is. So 8.314 divided by V is what? Molar volume. Okay, V minus of B is this one. B T is we don't know, so T equal to B naught is 4 into 10 power minus 5 meter cube per mole inverse minus of B1 1.35 to 10 power minus 7 of T. Okay. What is come on a day. So you can 4 into 10 power minus 5 minus of 1.35 into 10 power minus 7 of T. Okay, this is the equation number 1. So என்னதுல இவ்வளோ பெருசாக கொடுத்துருக்காங்க பைத்தியக்காரங்களா. Wait. Mm-hmm. Literally, this is one of the best question in my point of view, guys. So you can see this one dou h with dou h like this. It means dou t go this side. Okay, dou h equal to v dp minus of T temperature dou v by dou t with respect to differentiation of pressure. Okay, so first we need to put the v here. Okay, oh, so v you can just put here p equal to rt p minus of bt. So v equal to bt plus of rt of p. Okay, so this one is NTTV, so put here. So bt plus of rt of p with respect to dp differential pressure minus of temperature T dou v, it means dou v with respect to dou t is so b plus of r divided by p. Okay, so temperature multiply r t of p with respect to differentiation pressure. Okay, where we are doing mistake. Guys, I think so you understood the concept, but literally, wow, it's fucking hard. So, RT. So you can see if definitely cancel with this comes, it will come 0. So definitely 0 is not at all possible here. So I'll just explain with this one. Okay. So you can see this one ds by dt or differential of okay. So this is RT divided by of BT. Definitely BT will come. Okay. So minus of dou v by dou t. This one. So wait. Okay, what is the value of here? BT B0 plus B1 of t. Body எங்கேருந்துடா வரீங்க நீங்கள்லாம்? ஸோ guys, literally it's one of the easiest question, but wow, literally I want to appreciate the person who made this question paper. So what is the thing? I need to just write in steps, but literally I even just confused. Okay, so this will be equal to bt plus of rt divided by p. Okay, bt is 1 on b0 plus of b1 of t. Okay, of plus rt of p. Okay, when you just dou v by dou t, you can see b1 t plus of r of p. Okay, this one is just wrote here. Okay, this one will be as it is. So bt, how we can just write b0 plus of b1 of t plus of rt with respect to p of dp. This one minus will be b1 of t plus of r of p of dp. Okay, so difference with respect to p means what will come? So you can definitely see which term will get cancelled. This thing, this. Okay, so you can see b0 of dp. Okay, integration. So up to where? So 5 to 15. So you can see b0 15 minus of 5 megapascal. What is the value of b0? பா அம்மாடே எங்கேதான் வண்டி நீங்கள்லாம் எங்கே தான் இருந்தீங்க நீங்கள் இதெல்லாம்? So put the value of b0 put the value of 10 here and you can calculate the answer 400 joule per actually I want to just clap. Sorry, it is one of the, in my point of view, it's one of the amazing question. So you can just go for the next question. So you can see in this one, a reversible constant volume non-flow process change in enthalpy. Yes. So next thing you can see for ideal gas changes using specific enthalpy, it is sufficient to know only the pressure, temperature. Okay, I think so. You can understand. So okay guys, then that's it for the video, and let me see the next video. Until then, take care, bye bye, have a good day.